Hey, what's going on, guys? Against here. In this video we'll create a function to generate moves for our chess engine. So if you're interested, without further ado, let's actually start. Okay, so def generate moves. It takes the self instance, and the very first thing we want to do is to loop over the board square. So I can say for square in range and the length of self dot board, and here we need to define our piece. So piece would be equal to self dot board indexed by the square. Okay, and now let's print our piece. So I'm going to be showing you this step by step just to give an idea how it works. So yeah, obviously I need to call this method here. So chess.generate moves, and here we go. So as you can see here, we've printed all the characters kind of like available within the board array, but we don't need all of them. So what we need to do now is the following. So here I can say if piece not in, and now the list of characters we want to avoid. So we don't want to bring the we don't want to consider the empty space, which stands for off board. Off board empty space, which stands for off board square. We don't want empty squares represented by the dot, and we don't want the new line squares that also stand for off board. So currently we already have the following thing. So all the pieces being traversed, but we need only those pieces that belong to the side to move. So if we have a look at our FEN, we see this kind of white to move currently. So here we will now make use of our colors array. So here it is. So colors to get the color for every single piece. So I can say and self dot colors and piece is equal to self dot side to move. So now we only pick up white pieces, which is exactly the case. Okay, great. So the next thing to consider, we need to loop over the move offset. So I can say for offset in self dot, and I just forgot the name, directions. Okay, in self dot directions indexed by the piece. So let's print the piece and the corresponding direction, the corresponding offset. Okay, excuse me, yeah, I just missed the column piece not defined. Sorry, so obviously it should be piece. Okay, and here we got the offsets for all the pieces here. Great. Okay, now it's time to define the target square. So I can say target square equals to square, and then we want to loop over the attack ray. So while true, and here first I want to increment the target square by the offset. So target square plus equals offset. Okay, and also define the captured piece to restore the captured piece on board later on. So captured piece is equal to self dot board indexed by the target square. So whatever we got captured, that would be the captured piece. And now to escape from this loop one happy day, I want to say the following. So if captured piece in and the range of characters, so if it's white space, which means offboard, or the new line character, which means offboard as well. In this case, we just want to break out of the loop. And also another thing to consider, we want to avoid leaper pieces from sliding, but first I will probably demonstrate how this works at current state, and then we're going to be adding the limitations defining the actual rules of chess. Okay, so now we can make use of this line print in the board. So I just want to copy this and paste. Okay, and here we want to make and unmake moves. We'll later separate this into a single method like make move, unmake move, but for now it's really enough to say self dot board indexed by the target square would be equal to piece, and self dot board and square, which means the source square, would be equal to 0. So we erase the piece there. Okay, and I'm sorry for this slight inconvenience. So here I want to say input, and here I want to say self, sorry for this, self dot board indexed by the target square. So here we'll restore the position. It would be equal to captured piece this time, and self dot board and square, and we restore the original piece there as well. Okay, and now let's print the board again, and so input just allows to search to wait for user input, and it's really handy for debugging purposes. That's how I debug chess engines at very least. Okay, so here we have the pawn sliding along the board, and all the direction, even the double pawn move. So this is definitely wrong, but already we have the moves being generated, which is really perfect. Okay, guys, so now let's well, it just takes a bit too long to walk through all of them, but I just want to give you an idea that the same happens with the knights, or probably we'll start with the rook. Okay, but yeah, then it happens with the knights, okay, and with the bishop. So now we want to prevent leaper pieces from sliding. So in order to do that, I can simply say if if piece in, and this might be pawn, white or black, white knight or black knight, white king or black king. In this case, we want to break. So let's have a look what we have. Okay, so now we have pawns only moving through their directions. Well, obviously pawns are capturing sideways, which is wrong, and it would be doing double move all of the time, which is also wrong, and it still captures own pieces. However, when it comes to knights, you see, like, knights are no longer sliding, and that's good idea. And the same should be with king. Okay, yeah, so the king is just going one step forward, and that's sort of it. Okay, guys, so the next thing to consider, we need to prevent our pieces from capturing own pieces. And this is done in a very simple way. So I can say if self.colors and captured piece is equal to self.side. So we have the color of captured piece exactly the side that decides to move. In this case, we just want to break. Okay, so here we go. And the rooks would no longer go anywhere. So you see, like, only knight goes, and we're done. So rooks are no longer going anywhere. Same with bishops, queen, and another rook, because we are no longer capturing our own pieces. But now another problem is arising. So let's consider that we don't have a pawn here, and it's really handy to use FEN as an input to initialize the board position. Now I just want to show you guys what's going to be happening with our rooks. So now the rooks will not stop when eating opponent's piece, so it should stop here. However, it jumps further on, which is wrong. So in order to fix this sort of a behavior, we can simply say if colors, if self.colors and captured piece, again captured piece is equal self.site but XORed with 1. In this case, we want to break. So what this line does, so we have the color of the captured piece is opposite to the captured the color of the captured piece is opposite to the side tumor. This means that we've the white has captured black piece or black has captured white piece. In this case, we want to break so we're not jumping over pieces, at least in standard chess variants. We do so in some chess variants, by the way. Okay, so let's test this again, and now the rook should stop by eating pawn, and yeah, and the rook stops. Awesome. Okay, now let's deal with our pawns. So so yeah, here I want to say there's too many spaces there. So if piece in black or white pawn, what we want to do in this case. So if so first let's handle the diagonal captures of pawns. So we need to disallow the pawn moves in case if the diagonal squares are not occupied by the pieces. So we can say if offset in, and let's look for the offset for pawns. So it should be -9 -11 and +9 +11. So let's say 9 11 -9 and -11, and captured piece and captured piece. So if captured piece is equal to empty square, in this case we break because pawns can move diagonally. Okay, so let's quickly check this out. Okay, so pawns are no longer moving to the sideways. However, if we just put something there, so let's put the pawn here, and let's say 2, and let's eat black rook, it would have been nice and it's gonna be fun. So now, oh, I'm sorry guys, I've done something horrible. Oh yeah, the FEN is malformed. I'm sorry, the FEN is malformed. 5 2 3, yeah, this is it, just the malformed FEN. Okay, so but we can capture another a bit of an issue that we can capture if going forwards. We'll fix that just right in a moment, but at very least we're no longer moving with the pawns diagonally without capturing. Okay, so the next condition is pretty similar, but we can say if offset in, and this time we need the frontal, like orthogonal offsets. So it would be 10 20. So we want to check the target square for double pawn push as well. So 10 12 10 20 minus 10 minus 20. So 10 20 minus 10 minus 20, and captured piece, this case is not equal to an empty square. In this case we want to break. So the idea is the following. So we go in with a pawn forwards, and it's not empty, so we just want to break. So we can't capture with a pawn like one step forward. It's not CNC or Jengi. It's Korean, Chinese or Korean chess. So here we can capture with the pawns. Okay, so it now should okay, it only jumps over the rook, which is okay for now. We'll handle this next, but it doesn't capture the rook if going forwards. Okay, great. Now let's prevent pawns from jumping over pieces. So we can say the following. So if piece is equal to white pawn and offset is equal to minus 20, because pawns are going forwards and it negates the offset. So in this case, I can say if and the in-between square, so self dot board and square minus 10 is not equal to empty. So if it's not empty in this case, we want to break. And also we need to do the same for black pieces, so for black pawns. So if piece is equal to pawn and offset is equal to 20, and this time if self board and square plus 10 in this case is not equal to empty, in this case we want to break. So let's check this again. Okay, and the C pawn, you see like C pawn is no longer going anywhere. This is great. But here is another one little issue. Okay guys, so I'm not checking for black side because I've been debugging this program for quite a bit of time, so I'm pretty sure this is going to be working. Okay, so one last issue we got here is the following. So let's restore the FEN and let's say pawn and 7, and here we don't have a pawn, and save. Here is another issue, one last issue. So you see like it makes the double pawn move not from the second rank, which is kind of wrong. Okay, so just to demonstrate this again, so 1 step forwards and 2 steps forward. So this is wrong. Now we need to prevent pawns from the double pawn push if they are not on the 2nd or on the 7th rank respectively. So let's implement this as well. So here we'll make use of our ranks. So if source square is not within the range of these squares for whites, then we break because it's not on the rank 2, and the same for the black pawn if it's not on the rank 7. Okay, so here we go, and let's put it first actually. So let's say if square not in self rank 2, because these are white pieces we want to break, and here I want to say if square not in self dot rank 7 we want to break as well. And if I did everything properly, it no longer makes double pawn push. So have a look at this again. So we just push from a3 to a4, drop back, and we're no longer touching the a pawn because it's not on the 2nd rank. And again, like I've been debugging this, so this is pretty trustworthy. Okay, so what else do we need to do in our move generator? So one of the very important things to consider is that Toyfish is so-called king capture engine, which means it doesn't have the square attack function, but when it captures the king, it just drops the search. So we need to we don't really want to return any moves in case if the king capture occurs in current iteration. But in order to implement this, we need to take care of one more little thing. So generate moves would be returning the move list. So here I define the move list. It would be just a list here, and here just before making and unmaking moves, I'll take this code to the separate functions later on, so it's okay. So here I want to say if captured piece in black king or white king, we want to return empty list, and then the matter of list being empty would be the exact condition for checkmate detection within the search. And on the other hand, otherwise, right over in here, we want to return our move list. This is pretty it. So the very last thing left here is actually, instead of making and unmaking moves, we want to populate our move list with the following data. So I can say move list dot append, and here, okay, so yeah, let's just make it a dictionary. Yeah, let's make it a dictionary. So we want the square. Yeah, actually, I don't remember how to call the variable. Yeah, let's call them like source, and this would be square, and then target, and this would be captured piece, and then the piece. I'm sorry, what have I done? Sorry guys. Target would be target square, then the piece is gonna be piece. To restore it back, say for pawn promotions, right? And also captured piece, so let's just call it captured, and it would be captured piece. Okay guys, I just really want to keep the videos short, so we'll drive the make, move, and take back function in the next part. And for now, I just want to make sure that we have some moves being appended to the move list. So here I can simply say like print, and I want to print the move list, and also I don't want to do any moves, and I don't want to print anything here as well. So let's have a look. Okay, so yeah, well, probably we can just loop over these pieces. So let's say for move in moves, and I just want to print the move. There should be 20 moves in the initial position, if only FEN is not malformed or something. So let's put it back here, save, and here we go. Noun type is not iterable. Okay guys, I just sorry, horribly wrong. Obviously return should be the same indentation as well, this one in particular. So return move list, yeah, for otherwise it's obviously not going to be working. So yeah, let's try to print the moves. Okay, here, yeah, perfect. So I hope now we can iterate. So for move in moves, and print the move, and oh man, okay, here we go. So it should be 20 moves. So 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10, which is good. Well, okay guys, obviously it's not the way how to test the real world mode generator, and if we do implement things like impedance capture and castling, which are dropped here for simplicity and for clarity, things like perf testing are being involved, and I've been doing numerous tutorials on how to do that in more enhanced chess engines like the one like the Bitboard chess engine in C, some JavaScript alternatives of almost the same engine, let's say. So you can find this on Chess Programming channel if you're interested. But here, as far as we're coding Toyfish, which is a toy engine, it's literally enough what we've just done. Well, okay guys, this is it from my side. So in the next video, we'll separate the make, move, and take back function. We'll take care of pawn promotions as well, and I'll show you the hack that we're supposed to be using in this particular implementation. And yeah, this is it from my side. So thanks for watching. Until the next time, and take care.